Hi friends, I'm your host Christine Hollino, and welcome back to another episode of Making Things Fun, Cool, and Sexy. In this week's episode, we go to the heart of Silicon Valley in Santa Clara to Trumpf, where they make all sorts of lasers and machine tools that help with manufacturing processes. They had a MedTech day where they educated the medical industry how their laser applications can make a big impact. They invited us to capture the event, and it was lots of fun. Let's go check it out. Hi, Eliana.
Hi, Christine. It's so good to see you.
Thank you so much for inviting me to Trumpf today.
Yeah, absolutely. I'm really pleased to have, organized Trumpf's very first MedTech Day here at our Santa Clara Laser Application Lab. And so inviting the people in and showing a bunch of technical presentations and live interactive demos. So glad that you're here and you're part of it, really.
Yes. And we have met because we're both ambassadors for Women in 3D Printing. Can you share a little bit of what you do at Trumpf?
Yeah, absolutely. And by the way, Women in 3D Printing is an amazing organization. I am industry manager for aerospace and medical, which means I help the sales organization here in North America just to reach more customers and potential users of laser technology. And the area that we're focusing on today is medical device manufacturing industry.
It's so exciting. Tell us a little bit more about what we're going to see today at MedTech Day in Santa Clara.
Yeah, of course. Well, we've got some amazing technical presentations, all on technical subjects of laser technology in laser marking, laser welding, laser ablation and surface structuring. And then we have a guest speaker, Joe Kempf from Alpine Laser, who's going to be telling us about tube cutting for medical applications.
So exciting. So it's going to be a fun-filled day with tons of laser technology, innovation, and all that fun, cool, and sexy stuff.
Yeah, and what is even more interesting is the people who are attending come from a wide variety of backgrounds, and it's also a great opportunity to network with them and find out what they're doing, listen to a bit of their struggles, see if anybody can help with their products. And basically that's the whole point of why manufacturing is fun, sexy, and cool, is because we're trying to incorporate that aspect of laser technology into their processes.
Awesome. I know that you had a MedTech Day in Costa Rica recently, and then you have one here. Do you plan on having multiple MedTech Days?
Yeah, definitely. The one that we organized in Costa Rica was our very first one, so we didn't really know what to expect. We know that a lot of US-based companies are also having their medical divisions in Costa Rica. There's a very wide range of experiences and highly educated workforce there. So the benefit of us going there was to reach that audience as well. And what we realized is that people really love interaction, person-to-person interaction, and getting hands-on with the laser equipment, and the laser demonstrations were so helpful. So yes, our idea is to expand this series wherever people are in need of education and outreach, and basically just a chance to interact with us and reach out to us.
Awesome. So I'll make sure to have your LinkedIn information, because you always post about your upcoming events so that our audience can also find out more about Trumpf and your MedTech Days.
Great, thank you.
Yes, and then let's go and have a look on the floor and the lab now.
Okay, let's go.
Let's go. Hi, I'm here with Tim. He is the laser applications engineer here at Trumpf. Tim, you are such an expert here and you love giving demonstrations. Can you share a little bit about what this machine does?
Sure. So this is the TrueMark Station 7000. It houses a true MicroMark 1020 laser, which is an ultra-fast marking laser. Ultra-fast lasers means we are operating at a pulse width of femtoseconds, 850 femtoseconds in this case, and that means you have minimal heat input into your material. You can do very fine and very precise marking applications coming from either black marking on any type of steel surface, plastic marking, which in many cases is very hard for lasers to achieve because laser light doesn't like to interact with plastic as much. Usually you use UV lasers for this. In this case, it's completely possible to do it with an infrared laser. And you can also do microprocessing, such as cutting applications with this laser system. And it's a fully 3D capable laser system, which means the full machine control and laser control is designed in such a way that 3D parts can be easily integrated into this machine. They can be easily designed, and the marking contents can be easily wrapped such that 3D surfaces can be marked without much hassle. So we just took this tube part, put it onto the machine, and put a circumferential mark onto different parts of the laser. It has a C-axis. It automatically turns to the locations it needs to be and can do QR code marking, DMC marking. There is vision capability that ensures that the positioning of your parts is correct, even if there is some let's say, tolerance within your fixturing, tolerance within the part design, to ensure that the positioning of your marks against the parts are always perfect. You also have the capability of using AI filters. You can read and you can grade barcodes within the machine configuration, so it is really designed towards being a fully integrated solution for especially the medical industry for marking of parts.
Got it. So as I was showing here, this Trumpf logo was marked while we were talking. And then you could also see down here there is a QR code. And can you share why would any parts want a QR code on it?
Yes, so in a lot of fields, and especially in the medical device field right now, it is very common for regulatory bodies to impose regulations where UDIs have to be placed on devices. UDI means unique device identifier. So basically you have to ensure that a device that is put into somebody's body or a device that is being used in surgery is completely traceable, so that if there are any manufacturing defects, the lot can be researched and the lot can be recalled, for example.
Wow. So this can probably do really small parts as well?
This can do really small parts, that is correct. So it is possible to do DMCs or QR codes as small as 2 by 2 millimeters. The module sizes can be as small as 50 to 60 microns typically. And with that, yeah, you can get really, really fine features on the parts.
So what other industries will need to use laser marking?
Yes, the consumer electronics industry has a lot of marking applications where you have traceability within production lines again. So medium-sized components to small components can be very easily outfitted with UDIs in order to enhance the traceability of those components. The automotive industry uses a lot of marking lasers. You have a lot of metal, you have a lot of plastics. Again, you can do plastic marking, not only in terms of discoloring the plastic, but also if you have a black plastic and then a clear plastic underneath, you do something called day and night marking, where you take the black layer off, you expose the transparent layer beneath, and then you backlight it. That is the way that you can make, for example, speed dials that only light up under certain conditions. So only when the backlight is activated.
Oh, that is so cool. So cool. Well, thanks so much for showing this awesome system and laser marking so quickly.
Thank you very much for stopping by at our facilities.
Yes, thanks so much, Tim. So I'm here with Bill. Bill, tell us what you do here at Trumpf.
Okay. I'm a technology center manager, and I run the sales team for the western half of the U.S.
Awesome. And today we had an awesome experience at MedTech Day for Trumpf. Mm-hmm. Share us a little bit of what these parts do.
Okay. So let me back up just a little bit and say we do a lot of application work. We do The company as a whole, we do about 10,000 application, or we receive about 10,000 application requests a year. We do about 5,000 applications on the laser side of the business. What we're showing in these displays, we've got 4 of them here, is different applications that we've worked on, but these are the non-confidential side of it. So the really cool stuff is hidden, but this is interesting technology in itself. So let me show you just a couple things, such as we have applications that are glass welding. This is a piece of fused silica welded to a piece of fused silica. So that's an interesting one that works very well for MedTech applications. This is a piece of fused silica welded to a piece of aluminum. So we can now weld glass to metals.
You could weld?
Yes.
No way.
And some of these applications to where we weld glass to metal are actually used for implantables for MedTech. And the reason why you would use that is your body breaks down any glues that you use to hold material together. So instead of having to go in and surgically remove those parts and replace them, maybe every 6 months, they can go in permanently because the glass to metal welds will not deteriorate.
Wow.
Yeah, it's neat technology.
This is very cool.
Okay. Other applications, this is actually showing welding pacemakers. So titanium pacemaker, a nice smooth weld, hermetically sealed all the way around.
Also very, very cool. Because this is, so I've had episodes on welding, right? But
Yes.
that's like manual welding.
Yes.
This is on a machine.
Yes.
Wow.
This was actually from one of our customers welding it with one of our lasers.
That's incredible.
Yes. Thank you. So just a variety of other applications. This is actually a new application for us to where we can cut the glass and chamfer the glass in one pass. And the difference is we're cutting the glass and we're chamfering the glass on both sides. Single pass.
Wow. Also, so incredible.
These are for like cell phones.
Oh, so like, let's say my iPhone has a glass screen,
Yes.
right? So very cool.
So what the chamfer does is make the glass much stronger, because if it's a sharp edge, that's the edge that your crack is going to start if there's any pressure on it. Other things, there's a whole myriad of applications that we have.
What's this right here?
Oh, this is from our machine tool side of the business. This is actually a stainless steel tube that they've cut a spiral all the way around.
Whoa, this is cool.
That's a bottle opener.
Serves as a bottle opener too.
Serves as a bottle opener. That was done on a True Laser Tube 5000. This was also done on that same thing. The difference on this, you could probably see this is a square tube. You can straighten it out. That was cut with a single system without any post-processing.
This was one piece?
That was one piece.
This was one piece. And then it was laser cut, and now
Yes.
it's a puzzle piece. Wow.
That's pretty cool.
That is very cool.
Okay. Other things we do, battery welding applications, welding bus bars on the batteries, welding thin foils. This one is a really awesome one. This is, I think it's about 50 micron thick foil, and it's dissimilar metals. That's copper welded to aluminum.
Oh, wow.
And it's a battery foil welding application.
And what industry would this be for?
That'd be for automotive, or it could be for medical. I mean, for, let's say if you use a nanosecond lasers, chances are it's going to be for automotive. If you really want to have the highest quality, longest lifetime batteries, people tend to use ultrafast lasers for cutting the foils, and then they step it up a notch on welding the foils also.
Wow.
Because once again, you cannot take it out and replace it. So yeah, it's just a variety of different applications. It's a real hodgepodge, but the reason why we do this is to have customers understand the different things that we can do with lasers, and it always starts conversations, and it tends to lead to something else.
Yes. One last thing, let's show
Yes.
them the laser marking here.
Okay, so this is laser marking on glass.
Very cool.
It's very cool. Now, do you see the two lines in it?
Yes.
Those two lines are modification lines. That was done with the same technology that's used for this glass. Feel free to break it on one of the lines.
I'm scared.
You gotta put some pressure on it.
Ah!
Now that you've broken this, typically this is going to be very sharp.
Yes.
If you run your finger on that edge, which was not cut with the laser, I wouldn't want to do that. I'm probably going to cut it. I have no problem with on that edge to where it's very smooth, and it's about 0.4 RA, so it's very smooth surface.
Wow.
So that is that's what we call laser modification using the lasers.
You guys, I just broke the glass and it's a clean, crisp edge. No broken shards. Wow.
And we've recently cut up to 20 millimeter thick glass.
Wow. Well, this is incredible. Your team members are waiting for me inside. They're going to show me your lab. So thanks so much for your time today, Phil.
Thank you, Christine.
Thank you. Hi, I'm here with Vinh Tran. He is Sales and Applications Manager for Precitec. Vinh, tell us what this cool concoction is right here.
So this is our automated inspection tool. We're using a technology called chromatic confocal line scanner. And what I'm demonstrating today is we're going to capture the 3D geometry of this nitinol tubing, laser cut nitinol tubing. And this sensor here is very fast and very accurate. And let me click on the run button here. And in a matter of a few seconds, you can get a 3D geometry of this tubing here down to the micron level of resolution. So we just did a scan, and let me pull up the results real quick here. And what you're seeing here is the 2D image, and you can see a very clear image that we can use for defect inspection, but not only the 2D part, we can actually capture the 3D geometry. So here we're actually capturing the 3D geometry of this tubing here. So it's a great tool for the lab, but then also being used the same sensor to be implemented in process, in line at the factory to automate your inspection process.
Very cool. So this is integrated into factories?
It can be, yes, yes. So we have a lot of applications in the consumer electronics, like phones, implemented, thousands of these implemented in the factory in China, producing your phones.
Got it. And when they're scanning, what are they looking for? Are they looking for certain dimensions, surface? What can it read?
Yes, so it basically we're capturing a 3D point cloud and allows us to measure the dimensions, the analysis, but also looking for defects like scratch, digs, things that we might not think about every day, but according to certain manufacturer, they care a lot about the quality that you're spending this high dollar amount onto your products.
That's very awesome. And what type of applications are being used for this?
So our main applications, consumer electronics, semiconductor, looking at wafers inspections, glass bottle, thickness of the glass bottle in your beer bottles, and then a lot of medical applications where traceability and high accuracy is required for the end user.
Awesome. And how do you partner with Trumpf?
So we've been partnered with Trumpf for a long time. We sell the laser head. We work with them on the laser head, and then they can implement their lasers for the laser welding and cutting. But then we're also involved on the metrology side to inspect the quality of the weld, or the quality of the parts that you're trying to produce.
Wow, this is really awesome. And have you incorporated any AI into your QC process?
Yes, so this is the ongoing topic here. So all our sensors, we're capturing a lot of information, and a lot of those information we're tracking from part to part allows us to AI to improve the quality, but then also improve the manufacturing process, hopefully bring the cost down to you as well.
Yeah, very awesome. But I'll make sure to add your contact information in the LinkedIn, your LinkedIn profile, so that everyone can follow you and see what cool technologies that you're bringing to the table.
Great, thank you very much, Christine.
Yeah, thank you so much, Vinh. Hi, I'm here with Cody. He is an applications engineer here at Trumpf. Cody, can you share what this system does?
Yes, so this is our True Laser Station 7000. It's a highly flexible welding system that is compatible with a variety of laser sources, such as continuous wave or pulsed lasers. It's also compatible with both our scanner optic and our fixed optic. Using the fixed optic, with the use of the rotary, enables 5-axis coordination of the system, which is useful for 3D applications. Additionally, high accuracy stages ensure quality for even the smallest parts, while the spacious build area allows for multiple parts or even larger parts to be processed. There's also a pneumatic and digital I/O interface that can be connected through fixturing and sensors in line. So we also have our image-based detection software system, Vision line, that uses dark to light contrast to find the start position of a weld.
Cool. And what cool thing are you making right here?
So this is a example of a stainless steel stent that we are welding a cap to the end of it. We're going to be doing this in a heat conduction mode weld. Before we do the final weld, we'll do a series of tacks to ensure that the part is held onto the part, and then we'll go around in a continuous wave mode to weld the final seam. And the requirement of that seam is it needs to be leak tight so that no air or liquids could escape from that weld area.
Very cool. And this is stainless steel?
Yep, so stainless steel to stainless steel in this configuration. So welding similar materials. Obviously, it being a homogeneous process is a lot easier for the materials to mate together.
And how is this different from a welder working in like a machine shop type of environment? How is this different?
The main difference between this system and traditional systems you would see out there is this is highly flexible and very automated. And then the other key difference would be effectively the small spot size that you receive or that you get from this configuration, leading to less damage of your parts and less heat put into the part. So there's basically, with the small spot size, is more efficient in doing its process.
Very cool. What other cool parts do you make on this?
On this particular system, we do a lot of 3D geometries, so tube to tube. It's highly flexible because of the optic that can rotate negative plus or minus 120 degrees. So it is very good at getting in tight to reach places.
And what types of industries would use this type of technology?
We see this system mainly in medical device and some battery manufacturing as well.
Very cool. Awesome. Well, thanks for your time today, Cody.
Yeah, thank you.
Yes. Hi, Joe. You're one of our special guests today. You're a special guest for Trumpf's MedTech Day. You're one of the founders for Alpine Laser. Tell us, how did you get into the industry?
So I got my start in the medical device industry on the engineering side of things. I was supporting production lines that were producing millions of guide wires a year. And I kind of evolved into a lot of delivery systems for minimally invasive surgical procedures like transcatheter heart valves and placing stents and things like that. And we saw a huge demand for laser processing when you get into those delivery systems that deliver those therapies through the vasculature in the body. So we transitioned into working on capital equipment, the equipment that's used to cut this type of product, where you can convert a rigid stainless steel or nitinol tube into something that's flexible that can navigate through the human anatomy to deliver therapies to various places within the body.
Wow. May I see that?
Absolutely.
So this, so how would this work? A doctor would put this into someone's body, or how does that work?
So this particular component could be used within a larger catheter assembly, and that could be used maybe just at the end of the catheter that needs to perform like some complex bending to go across different vasculature, or maybe there's a blockage or something that needs to be crossed. The catheter can be used to navigate that type of anatomy and get to the point of interest to place the therapy.
So this used to be a hard, rigid piece of tubing, and now it's flexible.
Yeah, so you can program various shapes. I mean, really whatever you can come up with in your mind, you can program into the computer and translate that into code that the machine can run to cut out any sort of geometry into the tubing. And by cutting different shapes, you can make the tube perform different and different parts of the tube. If it was the section of the tubing that was farther outside of the body, it can be rigid. The vasculature is pretty large and straight in that section of the body. And then at the tip, you could change the geometry of your cut profile so that one end of it is more flexible than the other.
Wow. We get parts laser cut, and sometimes there's like burr marks or burn marks. Mm-hmm. Do you get that with this technology?
So there's various ways to kind of counteract that by choosing the correct laser type. would be one of those options. We can use ultra-fast lasers. So Trumpf has the TrueMicro 2030 that we've integrated in many workstations. That's an ultra-fast laser that does not impart heat into the parts. You don't get any of those burrs or slag material that's stuck to the surface. Is one way to do it. But there's a lot of other tips and tricks we could go over.
Oh, very cool. So how do you partner with Trumpf?
So Trumpf is our laser vendor that we were working with right now. So Trumpf supplies us with the lasers and we integrate it into a workstation. Also, we utilize their team in the laser application lab a lot for selecting the proper laser type for the base material that we're looking to process.
Wow. So when you were a little kid, would you ever imagine you would be here co-founding a laser cutting company that will help with the medical industry?
I came from the background, my dad started a company, so I kind of was always around it. Not laser processing at that time, it was coil winding and things for medical, but I've been around it my whole life. I always kind of wanted to start a company. I couldn't have told you back then that it would have been lasers, but it was always kind of a passion of mine to start something on my own. Very
cool, very cool. Well, I look forward to seeing your company grow and you grow, and I'll share your contact from LinkedIn into the podcast details below so the audience can find you.
Fantastic. Thank you very much.
Yeah, thank you so much. That's a wrap. If you or someone you know would like to be on the show, we would love to have them on. Just drop me an email or shoot me a DM on Instagram or LinkedIn. Details are below in the description. And if you had a blast listening, remember to hit that subscribe button, share the episode, and help spread the love for manufacturing. Until next time, keep on creating, keep on innovating, and always remember to keep it fun, cool, and sexy.